Work, energy, and power. What is work? Can you say what is work? In your language, what is work? Later on we can understand what is power and what is energy. You don't have any idea?
Actually, work is like I have to work for it, like doing something.
Doing something. Doing something called as a work, as you said. Yes, na? I'll ask you the few questions to you. Every day you are going to school.
Hmm.
This is the school building. Front of the gate, who will sit always?
A watchman.
Watchman. Watchman is sitting, which means keeper some. He is observing. He is simply sitting. But you are paying salary to him. Is right?
Yes.
He is simply sitting on the chair. Everyone going inside, coming outside. Children are going, parents are going, visitors are coming and going. He is not at all doing anything work. The same work you do, you sit in front of your house. Mom will scold you. What, Pranav? You don't have any other job to do? You are simply sitting in before of the house? She'll say. But this watchman is paying salary, but you are getting scoldings from mom. Now, can you analyze who is doing work?
The watchman.
Watchman is doing work.
No, I am doing work.
Also doing work.
Huh?
Are you doing work?
The watchman.
Are you doing work? Because you are simply sitting before your house. Mom is scolding. Pranav, you have examinations. Go and study. Why you are simply sitting? She'll say. Yes, na?
So my mom is doing work.
No. What I'm talking. You also the person, he also the person, both are simply sitting.
Yes.
But he is getting salary, but you are getting scoldings. Both are sitting and seeing. Yes, right? This is the first case. In the first case, both are doing work? No, no.
No.
But we are paying salary to him. Second case. You want to go to from ground floor to 14th floor, somewhere over here. Highly top.
Okay.
To the staircase, very difficulty to go up to 14th floor. That is the reason you are standing in the lift. You are going by lift. Yes, right?
Yes.
This from the ground floor. I am front of you, but I'm not inside of. I'm observing. You are going, moving up to 14th floor. Have you did any work? Have you did any work?
No.
No. But you are moving, right?
Yes.
You didn't do anything work.
Oh,
Without doing work, how you went to 14th floor?
with the help of the lift.
With help of the lift. Oh, in this case, you didn't do work. But simply you are sitting here,
Hmm.
you are not doing work. We know that. Now you are moving inside of the lift. Again, still you are saying you are not doing work. Fine. Third case, I'll tell you. Just to get down the platform, train came. You got with the family lot of baggages. The porter, without asking you, he lifted the total baggages on his head. He is simply standing and seeing your face. You are here. He didn't speak to you, you didn't speak to him. Okay? Simply is carrying bags up to 30 minutes. Later on, he get down all the luggages. He is asking you money, porter charges. Can you pay?
He did not talk with me. He just lifted my luggage and
Sorry.
he was asking for money. So I asked, what did you do? I did not ask you to take my.
He didn't do anything work.
He just lifted. He lifted.
Lifted and carried for 30 minutes.
Yeah.
But why you are not paying him money?
Because he did not speak to me.
Okay, he's keep on speaking after lifting up the luggages up to half an hour. Can you pay him?
Yes.
Oh, if he carry and if he speak to you, can you pay him?
First, he must ask, can I help you? Then,
Mother will scold you na.
huh?
Mother will scold you na again on the platform. Why Pranav? Again you are paying him money. He simply carried and he is speaking to you 30 minutes. What is the use? She'll say. Is it work? Is it work? Okay, fine. Fourth case. You are going to school.
Okay.
You lifted your bag of books on your backside. Just you are simply standing for 30 minutes. Obviously your muscles will get pain. The same work also will get the pain here. Now, in this case, did you do the work?
Yes.
Did you do the work in this case?
Yes.
Okay, but why not porter? You said if he speak to you only, you will pay the money. But still time they carried the luggage, right? You also carrying the luggage over here. You are saying you are doing work. But porter also just is simply carried, but he is not doing anything work. We won't pay him. Yes, right?
Yes.
Yes or no? Now, can you analyze what is work?
So, work is.
Work is push or pull on an object.
That's force.
That is force. That's force, absolutely. But exactly not a verb. Force should be needed to do the work. Yes, right? But you lifted the carry bag. You applied some force, but no use. I'll tell you how. Say an example. You are pushing a wall. You are pushing a wall. Did you do the work?
No.
Why so? You carried the bag, then you are saying you are doing work. You pushed the wall, then you are saying,
Because the wall did not move at all. Because the wall did not move, but the baggage moved.
oh, wall is not moving. Wall is not moving. But you carried the bag. You are saying you are doing work. So finally what you understood? If you apply the force, if object moves something distance, that's called it as a work. Okay? Please note it down. Work is the product of force and distance. Work is the product of force and distance. W is equal to F into S. F into S.
So work is mainly the product of force and distance. Oh,
Work is the product of force into distance. Now, work is done when a force that applied to an object moves that object. Once you push the wall, work not been done. Whenever dragging the cart, then work will be done. That's right?
yes.
Next, according to physics definition, you are not doing work if you are just holding the weights above your head or lifting your back. You are doing work while you are lifting the weight above your head, means only movement. While carry bag, you should move forward. You have to go to the school. That time only you carried the bag. There is a something distance between you and the school. Clear? You are simply standing in the lift, but you not applied any force, but there is a distance. That's right. Finally, force is needed and distance also needed. Okay.
Okay.
Now, what I said, force into distance or displacement, whatever, it's same. Clear?
Okay.
Understood? Now, W is equal to F into S. If you calculate force is equal to W by S. Distance is equal to W by F. The same thing on the place of D, you mention as S, no problem, whatever the distance or the displacement. In a triangular formula, W is equal to F into S, F is equal to W by S, S is equal to W by F, which is in a shortest memorizing way. Okay?
Okay.
Next. When work done 0? When work done 0?
You are not able to move the object.
Yes. If object not moves, then work done will be the 0. And one more case. Force applied perpendicular to the motion. You lifted, you are carrying, force is this is the way. Yes, right? But there is no displacement, then you are not doing work. If you the motion is like this, S, F into S. That's right. Now, when is work done positive and negative? We will say the case 1. I'll tell you what is this. W is equal to F into S, which means Fs cos theta. Cos theta, newly you are learning. This is the trigonometric value. Trigonometry you can study in class 10th. Sin theta, cos theta, tan theta. Okay? Sin theta, cos theta, tan theta. These are all the trigonometric values. Clear? W is equal to F into S. Another formula, Fs cos theta. Now, if the displacement is in the direction of the force, then theta is equal to 0. This is the object. Force is applying. and the displacement also, this is the same direction. Now total angle will be 0. Once theta is equal to 0, this we can call it as a theta. Theta. Got it, Pranav?
Okay.
Theta is equal to 0 because the same direction the force. Now cos 0 is equal to 1. Cos 0 value 1 because on the place of theta we have to substitute 0. Once cos 0 is equal to 1, W is equal to F into S into 1. Clear? Which means F into S. In this case, work done positive. Clear?
Yeah.
In case 2, force is applying, this is the way, but the displacement is going, this is the way. Okay? Now you can see here, force perpendicular to the motion because you lifted the bucket. You are carrying, this is the way. Yes, right? In this case, the theta value, angle will be 90 degrees.
Also,
90 degrees, perpendicular. Because you are lifting, moving, this is the way. Between these two angle, 90 degrees.
but why we can move like this also?
Sorry?
You can move like this.
I'm not hearing your... you can. Whatever. You can move, this is the way also. But not this is the way.
Which way?
Okay? You can move, this is the way or this is the way. Whatever, angle will be 90 degrees. So, now cos 90 is equal to 0. Now W is equal to Fs cos 90. Cos 90 value will be 0. So F into S into 0, which means W is equal to 0. In this case, work done will be 0. Got it? Are you writing?
So cos 90.
Please note it down. Please note it down, the case 1 and case 2. They're asking too much question. Please note it down, Pranav. Please use the rough notes and note it, these two cases, in a shortest way. Can I continue?
Yes.
Now, case 3, when it will be a negative. Now, you are applying the force. You are applying the force on an object, and this is the way. But the frictional force in opposite direction. Yes, no? For example, there is a suitcase or whatever, the block, which you applied the force F. Opposition force is frictional force, right? Between these two angle, how much? 180 degrees, because a straight line, 180 degrees. Now, theta angle will be 180, cos 180 value minus 1. Okay? As you know, W is equal to Fs cos theta means cos 180. Cos 180, whenever it is minus 1, F into S into minus 1. You can write minus F into S. Yes, right? In this case,
Why did it become -1?
because cos 180 value minus 1. Cos 0, how much? 1.
1.
Cos 90, 0.
0.
Cos 180 minus 1. So these are all the fixed values. Later on, the next year you can study them. Okay?
Okay.
Please note this. Next. The units of work, joules. Okay? Units of work, SI unit is joule. W is equal to force, joules. Units of work, joules.
Joule.
1 joule is equal to, what is the units of force? Newton.
Yes.
What is the units of distance? Meter.
Meter.
So 1 Newton meter is equal to 1 joule.
So this is equal to 42 meter.
Yes. So 1 joule is defined as the work expended by a force of 1 Newton through a distance of 1 meter. And bigger units of work, kilojoules. Kilo means 10 power 3 joules. Megajoules 10 to the power of 6. Gigajoule 10 to the power of 9 joules. 10 to the power of minus 9 joules, nano. Hope you heard this word, nano. 10 to the power of minus 6 joules, micro. 10 to the power of minus 3 milli, you know already. Yes, no? So this is the way. Have you noted?
So like what is the, that is milli, this is micro, and that is nano.
Yes. 10 to the power of 6 mega. 10 to the power of minus 6 micro.
Okay.
10 to the power of 9 giga. 10 to the power of minus 9 nano.
Okay.
10 cube kilo because 1000. 1000 means
Okay.
kilo. 10 power minus 3 milli. That's right. Note it. Next, scientific conception of work. We have discussed the some things we discussed, activities. Now, what is the work done? Work being done on. What is happening to the object? What is doing to the work? This is a small activity. Now, you can see the case 1. Kamali is preparing for examinations. She spends a lot of time in studies. She reads books, draws diagrams, organizes her thoughts, collects question papers, attends classes, discusses problems with her friends, and performs experiments. She expends a lot of energy on these activities. In common preference, she working hard. Yes, right? What is work being done on? Here, the work is being done on the thoughts processes required to understand the text. Is right? What's happening to the object? The thoughts are getting generated. This is happening as outcome. And who is doing work? Kamali's brain is processing thoughts to make her study. Hence, her brain is doing the work. Okay? Now, second one. Rahul is working hard to push a huge rock. Let's say the rock does not move despite all the efforts. Rahul gets completely exhausted. What is the work being done on? The rock. What's happening to the object? Rock does not move. Who is doing the work? Rahul is doing the work. That's right. Have you observed the two cases? Who is doing work and who is not doing work?
Yes.
Now, case 3. Parvati stands still for a few minutes with heavy load on her head. She gets tired. She had exerted herself and have spent quite a bit of her energy. What is the work being done on? The load, what is carrying. What is happening to the object? The load does not move. Who is doing work? Parvati doing work. She also didn't do the work. That's right. Now, this is one activity. Please do that from your end. Okay. Take a snapshot of this. There's a snapshot symbol will be there, which is the left side. Just take a click and try to think the scientific conception of work.
So at the end of the session,
And later on you think about your practical work, whether you are doing work or not, and which cases you are doing work, which cases you are not doing work, or whatever, any case. Okay. Next. You can think many situations. Next. Work done by a constant force. Let a constant force F acting on an object while displacement is being S. Let W be the work done. We define work to be equal the product of the force and displacement. Finally, you need to understand what is work. The product of force and displacement. Clear? If displacement is not there, there is nothing work. Clear? Next. Now you can see 5 newtons of force you applied here and 2 meters the block moved. Okay, 5 newtons you applied force, which means F is equal to 5 newtons. How much distance moved? 2 meters. So what is work? W is equal to F into S, which means 5 into 2. 10 Newton meters or 10 joules. Clear? Next. Let's see. Can you answer your question? Can you answer this? How much? 56 joules. Which option? Option C. How option C?
work is equal to force into Fs.
Very good. Exactly understood now. Force how much? 7. Distance 8. So 56 joules. Wonderful. Now, so what's the work done by the gravity? Gravity also applying force, right? There is a mass m of height h which comes down. Yes, right? W is equal to force into displacement. The force on gravity F is equal to m into a, as we know that as per the Newton's second law. Okay. Now a means acceleration due to gravity, mass, the mass of a body, which means m into g. Okay. Now the displacement by the object is h. W is equal to, you know that, F into S. S means distance, height h. F into h. F is equal to what we got it? mg. mg h. W is equal to. So this is the work done by the gravity. Please write it down. Fine. Now, can you solve this answer? A porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. How much you got it?
225.
225 joules. Can you explain how you got it?
Work is equal to m mass to gravity into height.
Okay. You applied a new formula.
Yeah.
W is equal to mgh. Okay. Mass how much?
15.
15. Gravity? How much you took?
Gravity is I think I took it as 1.
Gravity 10 na? 9.8 or 10? We can take it.
10.
Height how much?
1.5.
1.5. So you are selecting option B, right?
Yes.
Okay. Let's see. Wow. Very, very good. So this performance you have to show that always. So this is the way. MGH or MGS, whatever. Is the work scalar or vector quantity? Work is the scalar quantity or vector quantity? Have you remember what is a scalar and what is vector?
And scalar means it has only magnitude.
Yes, but no direction. Excellent. Vector?
Magnitude and direction both.
Magnitude and direction. So now work is vector or scalar?
Vector.
Vector. How?
As it even has distance. Sorry, direction.
Okay. Force is under particular direction. You mean to say. Is a scalar.
How, sir?
See, you are doing work.
Okay.
If somebody asks which direction you are doing work, you can't say. Right?
Yes.
You are doing work. Some joules of work done by the machine. Which direction? We can't say. You have to think logically. Next, this question.
An object moves in a circular motion at constant speed. The amount of work done by a centripetal force.
Okay. Which option?
Where it is moving in a circular motion and it's like you come back to the starting position, so there is no displacement. So it is zero.
Very, very good. Now, can you say the answer?
500 into 10 into 4. Two thousand J.
I guess this is the last question to you. You can able to answer for the next class. This much value will come. Okay. Now, these are all the questions. Please take a snapshot. This is for your homework assignment. Fine?
Okay.
All the best. We'll meet you in the next class. Bye for the day. And if you have any doubts up to this,